Hello, Mrs. Wagner here. I'm in Unit 1, Lesson 6. This is Experiment 2, Freezing Lauric Acid. So I just wanted to share with you what I have. So I have here some lauric acid. So what I'm going to do is try to bring this a little bit closer to the camera. And I want you to observe what that looks like. Okay, you can see it's very clear. It's got kind of a yellowish, very faint yellow tint to it. I do have a thermometer in there, but you can see it's pretty transparent, right? So I have it sitting in some water. Okay, clear, transparent, a little bit of a yellowish tint is going to be how we're going to describe it, and it's in a liquid state, okay? The thermometer, I'm going to read in Celsius. It is at 40 degrees Celsius. So I'm going to put that in the data table for our starting temperature. So now what we're going to do is place it into some cold water right here. And I am going to time this every 15 seconds. I'm going to time this. And every 15 seconds, I'm going to look at now it's dropped. So now it's at 38. So we'll call that the first 30 seconds. We're going to plunge it in some cold water. I'm going to do that quick because we can see that this is dropping. And every 30 seconds, we're going to read its measurements. Get this placed in there. And then we'll just be collecting data. Okay, it's been another 30 seconds and it is now at 31 degrees Celsius that we can see it's dropping in its temperature. Okay, so I'm going to hit start. All right, it's dropped to about 28 seconds, or I'm sorry, 28 degrees Celsius. So like I said, it's going to be every 30 seconds. All right, we are at 22 degrees Celsius. And I'm just watching my clock. And every 30 seconds, I'm taking a reading. Okay, it is at 18 degrees Celsius. A couple things we might start noticing is, I'm just going to stick that there. You can see kind of at the bottom here. All right, it is. So you can even see my thermometer's got a little bit of white stuff on it. All right, it is at 17. No, it's lower than that. It's below the 16. Okay. So you can see the thermometer, if you see the white on the bottom of the thermometer. Okay. So it's starting to become a little bit cloudy. All right, it is at 15 degrees Celsius. We can see, make some observations here. It's starting to cloud up a little bit down at the bottom. We can even see, try to turn it around a little bit. It's starting to become a little bit cloudy up throughout. Okay. All right, we got to be reading these. So now it is at 13. All right, we'll take another reading. It is at, well, 13. All right, we can see that it's a little bit more white down at the bottom there. Not as transparent, becoming a little bit more translucent. Okay, it is 12 degrees Celsius. So in our data table, we can see it took quite a plunge the first couple minutes, and now our temperature is slowly dropping. All right, it is at 12. All right, we'll do another reading. It's at, oh, interesting. It's gone up. It's gone up to 13. All right, we can see it's becoming really, really opaque now. This is becoming a white substance there. And it's kind of, I can feel when I press the thermometer down in there, it's kind of sticking to the substance. Yeah. Well, it's still 13. All right, it is now going up to 15. So interesting, it kind of dropped pretty quick, and then now it's kind of going up a little bit. Oh, I'm having a hard time getting the thermometer. All right, interesting. It's now at 17. All right, it's now at 18. We're almost 7.5, 8 minutes in. It's at 19. What's happening? Started out at 40, took big plunges down to about 12 was its lowest. Now it's starting to rise up. Remember, this is Celsius. What do we know about this temperature right about now, which is 20? What's 20-ish degrees Celsius? We've taken a lot of temperatures among things around the room, right? All right, we're at 20. I don't know if I can move that. We're at about 600 seconds. You okay? It's now 19. We're just going to give it a couple more minutes. It's settling 19 again. Okay. All right, what do we see going on here? Do you see the white? See if we get rid of the condensation on the outside of the speaker. So we can see that it's now, I'll pull it out too, but it's this white substance now. All right, it is 19. All right, we'll give it 10 more seconds for our next reading. 19. What do we see happening here? Oh, it's gone down to 18. Definitely going to 18. So remember, we're measuring the average kinetic energy of the particles. So the particles are moving. So this is why temperature, can go up and down like this, because we have an energy transferring from the warm lauric acid, which is a liquid, which was at 40 degrees Celsius, and it's giving its energy to the cooler water. It's losing energy to the cooler water. And it's doing that because the particles are slowing down. So the temperature is just an average kinetic energy number. Oh, it's at 17 now. Nope. 17. All right, I'm going to pause the video for the last minute or so. I'm going to pull this out of the cold water, and we'll get our last two readings outside of the cold water. Okay, so I've taken it out of the cold water. So now the energy, it's very cold, okay? As we can see, it is about, right now, it's at 17. Oh. Okay. It's very cold though. So now the energy transfer is a little bit different. So instead of the lauric acid giving its energy to the cold water, the air around it, which is warmer, is giving energy to the lauric acid. So we're not going to run this long to see it go up to room temperature. Right now it's up to 18. So it's heading its way back up to room temperature. Okay, so this is called freezing lauric acid because we took a liquid and we froze it. Okay, and our temperature is nearing room temperature. So for lauric acid, it freezes at room temperature, and we just did it very quickly by using the cold water. All right, so I'm going to let this just kind of sit for, I don't know, for however long it takes, and then we'll watch I'm going to pause the video and then I'll come back to it when it feels a little bit more like room temperature, but already I can see that the thermometer, it is going up very slowly, making its way to room temperature. Okay, so we're just going to kind of end this. As we can see, our test tube now, if you were to make observations, the lauric acid is an opaque white substance. It's solid. I'm not going to pull the thermometer out because I don't want to break it. But look, I can even hold on to it by the thermometer and it stays in there. So that's a solid substance. A little bit of the liquid still at the top because this has not frozen yet. So when it becomes a solid, it will become frozen and it will freeze. It will freeze at room temperature. So you can kind of see the little particles, little substance in there starting to freeze even outside of the cold water. All right.